Good afternoon, everyone. We are launching again our next edition of the Ranchers Thursday Lunchtime Series. We're happy to have you this afternoon. Dr. Lallman and I are on today. Dr. Lallman is in one of our county offices and so doesn't have access to his video. But Dr. Lallman, I'll let you go ahead and say hello.
Welcome, everyone. Thanks for joining us today. Today and one more week of this series. And then, hey, by the way, if you have ideas or suggestions for series in the future, just type those in the chat and we'll give those serious consideration. Thanks for joining today.
Absolutely. As a reminder, if you have questions as we go along, you have suggestions for future webinars, future topics, don't hesitate to put those in the Q&A and the chat. We will address all questions at the end of the presentation today, and we're very fortunate to have Dr. John Gilliam join us. Dr. Gilliam, I'll have you go ahead and bring up your slides. I'll give you a little bit of an introduction while we're doing that, and then we will get rolling. Dr. Gilliam is no stranger to the Ranchers Thursday Lunchtime Series. You've seen him here a time or two before. He's currently a clinical professor in the College of Veterinary Medicine, Bourne Veterinary Medical Hospital here at Oklahoma State University, where he teaches livestock medicine and surgery. He grew up in rural Oklahoma and completed his bachelor's in animal science as well as his veterinary degree here at Oklahoma State before entering practice. After a few years of private practice, he completed a residency in large animal internal medicine as well as a master's in veterinary biomedical sciences here at OSU. Before joining the faculty, of course, and he joined the faculty here at OSU in 2009. He's a diplomate of the American College of Veterinary Internal Medicine, Large Animal, as well as a diplomate of the American Board of Veterinary Practitioners, Food Animal. Since 2009, he served as the Food Animal Production Medicine and Field Services Clinician for the Bourne Veterinary Medical Teaching Hospital, and his research interests primarily focus on the welfare of food-producing animals. So with that, Dr. Gilliam, I'm going to go ahead and turn it over to you, and we'll answer questions when you get finished up.
Sounds great. Thank you very much, Dr. Biggs and Dr. Lallman, for having me on again today. I appreciate the opportunity to come and visit with everyone. Hope everyone's doing well out there. And let me get this moved out of the way there. There we go. So goal today is I'm going to present a small research project that we completed. The data was collected back in 2020, but has been recently published. And then we'll kind of go at the end, kind of over some things places where I think maybe this data takes us and wants us to kind of lead us to go to in the future. So with that, we'll go ahead and get started. And so the objectives of this study was to look at the prevalence or to see how common anthelmintic or dewormer resistance is in Oklahoma beef cow-calf herds. We've heard about resistance being an issue for on and off for several years. We know resistance is a major issue in the sheep and goat production world, but really just didn't have a great idea how much of a concern it was in beef cattle in Oklahoma. And since cow-calf is the major focus of beef production in Oklahoma, that's kind of where we thought we would start. And then as a secondary objective, we wanted to evaluate the use of composite fecal samples for assessment of anthelmintic resistance. One of the challenges is the expense of testing. And so if we can do composite or pooled sampling to assess resistance at the herd level, that may be a feasible option for allowing us to assess efficacy of our anthelmintic programs while reducing some of the cost of the process. And so we wanted to look at that as kind of a secondary objective of the study. This study was entirely funded through internal funding here through the OSU CVM. And so before we get started, I just want to touch base on the primary methodology that we have available to assess response to dewormers in livestock species, and that's the fecal egg count reduction test. It is a pretty simple, conceptually, thing to do, although it comes with some significant challenges, and consistency in how it's done is really critical to getting meaningful information. But the way it works is we just simply collect a fecal sample from the animal prior to treatment. Then we go ahead and treat that animal, and then we come back in about 2 weeks, typically 14 to 21 days. And that ideal time frame varies a little bit depending on the specific parasite that we're targeting, and also the product that we're using, because those products, some of the products have residual periods that last longer than others depending on the parasite. But somewhere in that 14 to 21 day time frame is the ideal time frame most of the time. If we wait too long, then the risk becomes that we got a good response to our Anthelmintic product, but that animals had time to go back out on the pasture and pick up new parasites, and then those new parasites start shedding eggs in the feces, and so it confounds our numbers, and we don't know how to interpret those. And so that's why that time frame is important. So somewhere in that 14 to 21 day window is where we typically target. We're going to send those samples to the lab or to your local veterinarian. Most veterinarians can conduct these counts in their clinic. They don't require any real specialized equipment. They just require attention to detail, but nothing's too specialized in terms of equipment. And we're going to count the number of parasite eggs observed in those in the feces in a gram of feces prior to treatment, and then we're going to count that again after treatment. And what we're looking there for is a 90% reduction in egg counts. And that 90% is kind of the established threshold that tells us we have adequate response to our dewormer product. Some references will say that should be 95%. So it kind of varies, but somewhere in that 90-95% range. If we can get above 90%, generally we feel like we're doing pretty good. And then anything below that becomes a concern. And certainly the further below 90 it becomes, the greater the concern that there's significant resistance in that particular population of animals. The test does have some significant limitations. Like I mentioned before, just being consistent with lab methods is absolutely critical. There's a lot of variation in egg shedding between animals. So some animals in the herd may shed a lot of eggs and others may not. And even within the same animal, there can be variable shedding. And so some animals may shed heavily on some days, depending on what the parasites in their GI tract are doing, and they may shed fewer eggs on other days. And so that variation makes this test a challenge and is one of the primary limitations to this methodology. Another concern is that when we treat an animal with a dewormer, in some cases, the dewormer, if it doesn't outright kill the parasite, it may go ahead and reduce their egg shedding temporarily, but not kill them. And so we think the animal responded well, or we think the parasites responded well by being killed by the dewormer, but really what we did is suppress the egg counts and not really kill the worms. And so they come back and begin to start producing eggs again later on. We don't really have a way to measure that, but it's just one of the limitations that we have to keep in mind when we're using this methodology. Another challenge is that in our livestock species, ruminant species, most of the parasites of concern, their eggs look very similar, and we're not able to differentiate them by species of parasite just by looking at the egg under a microscope. And so we can tell they have parasites there. We know which parasites are the predominant ones in cattle or in sheep or goats, depending on what we're dealing with. But we can't look at a parasite egg and say which species of parasite it is exactly. And like we mentioned a moment ago, it can be expensive. We generally are going to want to test, and we'll get to this in a minute, but somewhere around 20 animals in a herd. And so that's going to be, around 40 samples total to do that twice. And currently our diagnostic lab charges about $25 a sample to do those. There may be some opportunities for some volume discounts that we simply have to contact the lab for, but that's a fairly substantial investment, looking at about several $100s there to get this done on a typical beef herd. And so that's one of the main limitations of why we don't do a very good job of monitoring efficacy of our programs. But as you'll see as we go through this presentation, I think we need to start paying a little more attention to that. So and even though there's some limitations to that fecal egg count reduction test, it is currently the only way we have to assess Anthelmintic efficacy. Kind of the gold standard method is to sacrifice animals, euthanize some cattle, and then have some poor individual have to go through that GI tract and actually collect and count the actual parasites. That's a more accurate way to do it, but it's certainly not practical for application in a commercial production setting. So we're left with the fecal egg count reduction test, but it is important to remember the limitations of this test. And it's important that we really try to be as consistent as possible in our methodologies, both in sample collection, sample handling, and in the laboratory procedures to minimize those variations, and that way our data is as reliable as possible. So just a real quick background, won't spend much time on this, but like I said before, we know anthelmintic resistance is an issue in sheep and goat world. There are some reports of it in cattle as well. And these these papers listed here are kind of the first report. These three here are the first reports of anthelmintic resistance published in beef cattle. These were calves out of the southeast U.S. These two papers by Gaspar et al. Were calves out of the southeastern U.S. that were kind of assembled together, multi-source calves, sale-born calves, grazed for a little while in the southeast, and then sent to a stocker operator in Wisconsin, and that's where the resistance was discovered, because they started having clinical parasitism, and they had treated the animals for parasites. Like they used the same protocol for something like 17 years with good results, and then all of a sudden they started having clinical parasitism, and as they investigated that, they realized that they had significant resistance to multiple dewormers in those cattle coming out of the southeastern U.S. And then the paper there by Edmonds et al., that's a similar study, but those cattle originated in California, were sent to a feedlot in Idaho, and the resistance was discovered there while the cattle were in Idaho, but they had originated from California. And I just include all those to kind of show that it's not just the problem out of southeast cattle or cattle out of the west. It's a problem that we are starting to see kind of across the country, although we just don't have a lot of reports yet to go by. And then the NOMS beef calf survey from 2007, 2008 listed there. As part of that survey, producers who participated in that survey had an opportunity to send fecal samples in for evaluation, and then they would send a sample in later, after 2 weeks after treatment, and they looked for resistance and then reported that back to those producers. And what they found for herds that came out of the southeastern U.S. And Oklahoma would be included in that in this particular survey, about a third of the herd has evidence of resistance. There were only 4 herds from Oklahoma that participated, and 2 of those had evidence of anthelmintic resistance. And so very small numbers for the state of Oklahoma, but some evidence that maybe we do have an issue. And so that's kind of what led us to go down this road of trying to do this little survey study that we did back in 2020. As far as the composite sampling goes, there is one published report of doing that. And they compared, they did individual fecal egg count reduction tests, and then pooled samples and did fecal egg count reduction tests, and did those over 14 different groups of cattle with a wide range of parasite levels. And they found very high agreement between the individual samples and the pooled samples when they assessed those for just the evidence of resistance at the herd level. Obviously, pooling samples or using composite samples doesn't allow us to evaluate individual animals, and the fecal egg count reduction test is not great for looking at individuals anyway, because of all that variation that we talked about before. But at a herd level, as long as we sample enough animals, it can be more reliable. And they have found a very high level of agreement there between doing the samples individually versus pooling them. So that was encouraging, and so we wanted to try to see if we could repeat that with our study to give us a little more confidence in that methodology. So what we did is we just recruited beef cow-calf herds from around the state. We recruited herds from some of my local clientele here. Other veterinarians around the state participated and had clients participate in the study. And then we also multiple extension personnel helped us throughout the state and helped us identify producers who were interested in participating. They also helped with collecting samples and getting those samples sent to us. So we did just like we talked about before, we collected samples prior to treatment, and again, about 14 days later. Our goal was to get about 20 calves per herd. Somewhere in the neighborhood of 17 to 20 animals has been identified as the kind of representative sample that is enough to kind of account for the variation, and then a small enough number to try to minimize the cost and labor. So somewhere in that neighborhood of 20 head per herd is kind of ideal. And then we didn't control anything beyond that for this study. We didn't control what products were used, how they were used, when they were used. We just wanted to look at what producers were doing currently and assess how well those procedures were working. And we did ask producers to sample the same calves pre and post treatment. That when producers submitted those samples as part of the NOM study, they didn't have to sample the same animals pre and post treatment. So that's a big limitation of that study. So in order to overcome that, we did ask them to sample the same sets of calves or cows pre and post treatment. But other than that, we didn't control what they did. We didn't alter any of their herd management practices. We just wanted to look at what they were currently doing. And then we asked them to submit a short survey that just kind of answered several questions about the herd management, so we could have the opportunity to look and see if we could identify any aspects of herd management that maybe made a herd more or less likely to have evidence or have concerns with resistance. So again, we did fecal egg counts. We used a Wisconsin method. There are other methods that could be used, but fecal egg counts in cattle are typically low compared to those in sheep and goats, and the Wisconsin method is the most appropriate method to use when fecal egg counts tend to be low. For our composite samples, we took 1 gram of sample from each animal and then created a composite for that herd, and then performed the same fecal egg count reduction test on that composite sample. In order to get meaningful results, we do have to have a minimum number of parasite eggs present in the pre-treatment sample. If it's, down around, 10 eggs or less, or, few eggs, then we really can't make a valid conclusion on such a small number of eggs. And so we went through, and anything that had less than 25 eggs per gram in the pre-treatment sample, we did not include those samples or those animals in the final analysis. And then we just calculated the percent reduction, and looking for at least 90% reduction to consider the response adequate. We had a total of 19 sample sets submitted. There were 2 herds that were big enough to submit 2 sample sets. So we had 2 groups of 20 calves from each of those herds. And we actually used a different product in the 2 sample sets. So we were able to compare 2 different products within a given herd for those 2 herds. But for the rest of our herds, it was just 1 set of calves from each herd. So we had 19 sample sets from 17 herds. We ended up with 16 of those in the final analysis. When we went through and looked at that 25 egg per gram minimum, we had most herds had a few animals that had to be dropped out, but there were 3 herds that didn't have any animals at all that had more than 25 eggs per gram, and so those herds were excluded entirely. The number of animals per sample set ranged from 10 to 29. And again, that varied depending on what was submitted to us and then how many had to be dropped out because they didn't meet that 25 egg per gram minimum. But somewhere we had somewhere that once we dropped everybody out, we ended up with about anywhere from 8 to 24 calves in a sample set in the final analysis. And then we had a total of 13 composite samples. Once we went through and removed those that didn't have adequate pre-treatment counts, we had 13 for the final analysis. This is the distribution of those herds from around the state. So you can see we kind of had herds from all over the state. Though the red 3 there in parentheses indicate those are the 3 that had to be excluded from the final analysis. So 3 of the 4 herds from the northwestern part of the state didn't have enough parasites in any animals to be included in the study. But otherwise, the rest of the regions were able to include enough animals to keep those herds within the study. And then this is just kind of the survey that we asked people to look to complete for us. Were they a commercial or seed stock operation? Did they do continuous or rotational grazing? Primarily native grass or improved pasture? Did they deworm adult cattle or no? Did they weigh cattle before dosing or estimate weights? And then did they use what type of product? We did ask specifically what product, and we'll show you that data in a minute. But here we classified it whether it was an injectable, pour-on, or an oral product. And our hope was that we'd be able to go back and look at some of these management factors and say, okay, these are related to maybe a reduced risk of resistance or maybe an increased risk of resistance. And so that was why we collected this information. So here's the good stuff, the results of the study. When we've look at the individual samples, 13 out of the 16 groups failed to achieve the 90% level of reduction. So we had 81% of the groups of cattle that we evaluated had evidence of resistance. And those levels of reduction ranged from a negative 46%. So actually the fecal egg counts went up after deworming in those cattle, up to about 72%. So some of them were fairly close, but still didn't reach that 90% reduction. We had 3 of the 16 that had greater than 90% reduction, and they were all right around 99%. I think one was 98.9 and the others were 99% reduction. So very, very good response in those groups. And then you can see the range of responses in the 13 that failed to reach that 90% level. In our composite samples, 11 of the 13 failed to reach 90%. So 85% of the composite samples had evidence of resistance. And then 2 of the 13 were over 90% reduction. And so again, so both groups, whether we looked at individual samples or composite samples, an alarmingly high level of apparent resistance based on this method, which was quite a surprise to us. I thought we would find some resistance, but I did not expect it to be at this level. So very concerning. One neat thing about the study is that when we compared the individuals to the composites, there was perfect concordance between them. So that means if a herd was identified as resistant with the individual samples, that same herd was identified as resistant with the composite samples and vice versa. If a herd was not resistant in the individual samples, they were not resistant in the composite samples. So our numbers are pretty small here, but they do correlate well with that study published by George and others that looked at composite sampling previously and shows a high level of agreement between individual sampling and composite sampling. So that's encouraging from the standpoint of potentially being able to use this idea of composite sampling as a way to evaluate herd response going forward. Here's a list of the products that were included. Again, we didn't control any of this. This is just what producers were already doing. The number in parentheses is the number of herds that use that product. And then here are the results. So the numbers in red are the ones that were resistant. And then you can see the 3 herds there that responded to Safeguard. They responded very well. And we'll talk some more about that here in just a little bit and how do we interpret that data. But you can see that there was resistance to a wide range of products, both classes of products, both name brand and generic products, as well as different routes of administration. And so there wasn't any one particular product that was the problem. It was very widespread. And that's very concerning. So we'll talk some more about that here in a bit. Here's that survey data again, and I just added in the numbers to kind of show how the resistance fell among these different factors. So the numbers there in the red parentheses, the top number is the number that had resistance out of the total. And so just for example, there in the commercial operations, there were 12 that told us they were strictly commercial, and 9 of those 12 had evidence of resistance. And so you can look across there and see that there really isn't any one particular management aspect that stands out one way or the other. Every type of operation, every type of grazing management and pasture type all had evidence of resistance to some degree at least. If we look over here where they weighed before dosing, you can see that even those that were weighing calves still had some evidence of resistance. And it looks like there's maybe a difference there where, just over half of the herds that weighed their calves had evidence of resistance, whereas all of the calves that didn't weigh, all the herds that didn't weigh had resistance. So that may be something to pay attention to. We'll talk some more about that in a minute, but we didn't have enough numbers for that to reach any sort of statistical significance, unfortunately. And then you can see there with anthelmintic product types, all of the products had evidence of resistance potentially as well. So we were not able to identify any particular management factors that were of concern because, again, the level of resistance in this particular survey was so high that we just couldn't draw any conclusions about these different management factors and their influence. So it's a small survey, but it was a survey that was quite broad of Oklahoma beef cow-calf herds. It was broad in geography. You know, we got herds from all different parts of the state. We didn't have any herds from actually out in the Panhandle, but we did have herds from out around Shattuck, and so they were pretty close. We had herds representing all operation types in both commercial and purebred operations, commercial and seed stock operations. I guess I said that pasture types, grazing management. All of those were represented, and all of them had evidence of some resistance concerns to some degree. And so, a small survey, but a very broad survey that I think does a pretty good job of encompassing the Oklahoma beef industry as a whole. Even though the snapshot is fairly small, it's a pretty representative sampling of herds when we look at all the different types of herds that were represented and locations that they came from. So what does it tell us? It tells us that apparent resistance appears to be widespread among Oklahoma cow-calf operations. And I put that apparent there in quotes, and I think that's important to remember because we didn't control any other factors that could contribute to the results. And so it looks like these herds have anthelmintic resistance. And certainly some do, I'm confident. But we didn't control for some things that might have influenced that. So for example, we didn't control whether they weighed calves or not prior to treatment. And so we know that if we're estimating weights, some of you all may be very good at that. I'm not great at it. And so if we're estimating weights, there's a risk that we're maybe we're underdosing calves because we're underestimating their weights. Or if we're treating to an average weight, then we're underdosing half the herd if we're treating to an average weight. And so we thought that may be a big factor to influence the results. But even those herds that did weigh calves at the time of deworming still had some issues. And so it's not the only factor, but it certainly could contribute to the results. And so we say apparent resistance is because we can't say with 100% certainty that the results were because the anthelmintic products failed. There are other factors that may play a role, but what we can say is what producers are doing currently, or what they were doing at the time of this study, was not being very effective. And so the other interesting thing was that it was the apparent resistance was not isolated to a particular part of the state or a herd type or pasture type. All different types of beef cow-calf herds had evidence of concern. Even though our numbers are small, it still raises some concern because it wasn't just one particular type of herd that had issues. So here's an important part we need to remember in the interpretation of this information is this study was not really designed to compare anthelmintic products to each other. We did have the two herds where we were able to include two sets of calves out of each herd. And so that gives us an opportunity to kind of compare those two products within those herds. But beyond that, this study wasn't designed at all to compare products. And if you look back at that slide where I show you the different products that were used and what the resistance response was to those different products, fenbendazole or Safeguard was the only thing that was effective out of this entire survey. But it's very important that we recognize and remember how those products were used in the study. And so for the 3 herds that used fenbendazole, it was a novel product. It was a new product in those herds. It was not the product they'd been using over the last several years. And so in 2 of the herds, we tested 2 sets of calves, like I mentioned. One of those sets of calves got ivermectin, which is what the herd had been doing for years, injectable ivermectin. And just for comparison, we gave the other set of calves oral fenbendazole, and the ivermectin was not effective, but the fenbendazole was. And so that doesn't necessarily say that fenbendazole is a better product, but it's very good evidence that, you know, so when we use a dewormer product, you know, year after year after year, there certainly is the opportunity for resistance to develop. And then if we bring in a new compound, it's likely to be pretty effective. And so that's what happened in those two herds. The other herd just submitted one sample set, and they had switched to fenbendazole within the last year or so. So they had been using a variety of other products over the last several years, but had not used fenbendazole. And then prior to this study being started, they switched to fenbendazole a year or so prior. And so it was still a pretty new compound in that herd, and there hadn't been time for the parasites to develop resistance. And so don't take this study to say that everybody needs to go out and start using fenbendazole, but it does kind of give us the idea that if you've been using the same product year after year after year, it would be wise to do some evaluation and see how that product's working, and then maybe switch to a product of a different class. Had we had an opportunity to go into a herd and use a different product as a novel product, it's likely that that product might have looked really good too. You know, if we'd had a herd that had been using fenbendazole for 10 or 15 years and we went to ivermectin, we likely would have seen similar results in the response. So just good evidence of what a novel compound can do when the parasites haven't seen that compound in several years. But it doesn't mean that fenbendazole is the only effective dewormer out there on the market. So it is exciting that the composite sampling correctly classified all the herds. That's nice. Again, it's consistent with what was published in a previous paper. We do still need some more work on that to make sure it's going to be consistent, but it looks promising. And it may be a way to really reduce the cost of fecal egg count reduction testing for the herd and still get some usable data. So, you know, in that situation, the producer would still need to collect all the individual samples and submit those individual samples to the lab. And then the lab would do the pooling process because it has to be done in a consistent way in order to have meaningful results. So some limitations of the study, again, our numbers were quite small. You know, our goal was to get 20 herds, and we ended up with 19 herds. So pretty close there, but pretty small study. You know, we didn't control for a lot of things that could influence the results, like we mentioned, and so that's a limitation of the study. And then a lot of our herds did have pretty low pretreatment counts, and some to the point that we couldn't include them in the study. And we don't know exactly what the influence of those low counts would be. There's concern that it could influence the accuracy of the results. And that's why we set that 25 egg per gram minimum to try to reduce those concerns. But just things to keep in mind that, you know, there are some limitations to the study, as there are with any research study. So where do we go from here? What does this tell us, and how do we move forward? Let me check on my time here real quick, make sure I'm not running over. We don't have any anticipation of new anthelmintic products. There haven't been any in many years, and we don't have any on the horizon that we are aware of. If there's anything being developed, the companies have not released information on that. Some of you may be familiar with a new product released by Zoetis called Valcor. It's just been on the market here recently. It is a new product, but it's a combination of existing products. And so it is a doramectin levamisole combination. And so you get two anthelmintic products in the same product. And so you only have to administer one product, but you use two different products at the same time. So it's a new commercial product, but they're not new anthelmintic compounds. We'll talk here in just a second about combination therapy and where that might fit in. So because we don't have any new compounds, any new drugs on the horizon that would maybe come in and combat some of this resistance, we've got to find other solutions. We need to find other ways to manage it. And so our goal needs to be suppression of the parasites below an economic threshold where they're not causing significant economic loss, but while we're trying to minimize the selection for resistance. And so we know that anytime we administer an anthelmintic to an animal, there's the opportunity there to select for resistance, because none of our products are going to be 100% effective, and there's going to be a few worms left over potentially each time we deworm an animal. And if we do that long enough, those resistant ones become the predominant ones in the population. And that's when we start to see evidence of resistance at the herd level, when we've selected over time and those resistant genes in the parasites have become the dominant genes in the parasite population. And so we want to try to control parasites and minimize their economic impact and their production impact, but we need to start thinking about how do we do that while we minimize that selection pressure for resistance, because we can tell that it's a real issue now. So some easy things to do. One is just dose correctly. If at all possible, weigh the animals prior to dosing and dose according to the label directions. If we're underdosing cattle, we're giving them a subtherapeutic dose, and we're likely going to be selecting for resistance at a higher rate and more efficiently than if we're giving the labeled recommended dose to the animal. If we have to estimate weights, and that's certainly understandable, a lot of producers don't have scales, but if we have to estimate weights, we need to dose to the heaviest animal, not to the average. Because if we dose to the average, we know we're automatically, again, under treating half those animals. So what I do in those situations is I'll estimate weights of the herd, try to come up with what I think are the heaviest ones, and then I usually add some weight to it because I'm not great at it, and so I'll add 100 pounds or so to my estimate. We end up using a little bit more product, which increases the cost a little bit, but hopefully we're minimizing the opportunity to underdose because we're underestimating weights. And then the other issue, if you're using a pour-on product, I know those are super popular because they're really convenient. We really need to use those according to label directions. They need to be applied at the right dose, just like within the other type of product, but they also need to be applied in the right manner. They need to be applied, down the top line from the withers as far down to the tail as we can get, not just dumped all in one location, because that changes how the product's absorbed. Squirting stuff at a cow as they run by in the corral is not an effective strategy, and is a great way to help select for resistance. And so use the products correctly, the way they were designed. We want to think about how do we administer those products strategically. So how do we time that treatment so that we can minimize pasture contamination? There may be some years when we decide not to deworm. If it's really hot and dry, like last summer, we probably don't need to be deworming very much because the environmental conditions are not conducive to parasites being alive on the pasture in any significant numbers. This year is a little different, where we've had some moisture. So we may need to think about that a little bit differently. Generally speaking, what we want to think about is it's good practice to deworm young cattle about 4 weeks after they start grazing green grass, and adult cattle maybe about 6 weeks after they start grazing green grass, because the idea there is they start to pick up parasite eggs on the pasture when the pasture gets green. It takes those parasites typically in young cattle about 3 weeks to start producing eggs, a little longer in adult cattle because adult cattle have some immunity to the parasites. And so the idea is to go in and deworm them before they start shedding a lot of eggs out on the pasture. And that's kind of how we should try to approach that. And then we don't want to deworm a whole group of animals and then put them out on a clean pasture, because then they're going to be depositing some parasite eggs on that pasture, but they're only going to be depositing ones that didn't get killed by the dewormer. And so we're potentially creating a highly resistant population of parasites on that particular piece of ground, because the animals are going to be passing lower numbers, but what they're passing are all resistant or mostly resistant. And so over time, that could lead to resistance in that particular pasture. And then we need to also be using our products for only their intended purpose. We've got several anthelmintic products that also work on external parasites. All the ivermectin or avermectin type products have some external parasite activity as well. But anytime we use those products for flies or lice or whatever the case may be, we are applying selection pressure to the internal parasites in that animal as well. And so don't use products like long range for fly control. Don't use Cytectin Poron for fly control, because when we do that, we're also selecting for resistance in our GI parasites internally. Then we come to this idea of refugia. This is the idea that we want to try to minimize the concentration of those resistance genes in the animal population or in the parasite population. And so we do that by leaving some populations of parasites untreated so that we don't select them for resistance. And so the best way to do that is to leave some animals untreated, and that way their parasites, the ones they're carrying, are not selected for resistance. And so the eggs that those animals shed on the pasture still contain both susceptible and maybe some resistant genotypes. But the idea there is we keep those resistant genotypes less concentrated. We keep them diluted in the parasite population, and that helps slow the development of resistance. This has become kind of the standard practice for deworming small ruminants, but it becomes a bigger challenge for cattle. And so if you're familiar with sheep and goats at all and are familiar with this Refugia system, it works very well. And this is kind of what we recommend for all sheep and goat producers now, is that, and because the primary parasite that sheep and goats get is a blood feeding parasite. And so what happens to the animals, they become anemic. And so that's easy to see when we look at the color of their mucous membranes around their eyes. And if they're pale, they're likely heavily parasitized. If they're not pale, they're probably not heavily parasitized. And so we treat the pale ones and don't treat the other ones. Works very well. The problem comes when we come to cattle is that the primary parasite in cattle is not a blood feeding parasite. And so there's no way to look at the bovine and say this one's parasitized while that one's not. And so it becomes a real challenge to apply these Refugia concepts to them. So we have this idea of targeted selected treatment to try to maintain Refugia. And basically that is leaving some animals untreated, but the question is which ones? So different ways that it's been done. Some people will just, treat a fixed percentage of the group. So we'll just say, okay, we're going to leave 10% untreated. That's one way to do it. There are some thresholds that we can treat on based on, weight gain or fecal egg count, or we actually measure some enzymes that indicate parasite activity. But the problem with those methods is you have to get the animals in, collect the weight or collect the sample, get the results, then sort out who gets treated and not, and then bring them back in and treat them again. And so it's just not very practical in our beef production system in the U.S. And then another option is to treat some age classes, but not others. And so that's another way to do it. And the trouble is that we just don't have enough data to know which of these is best for cattle. These are all options. We just don't have a great way to know which option is the best. And so there's this idea of leaving adult beef cows untreated because we know they develop immunity to parasites over time. And it's an easy thing to do. Maybe we leave all the cows untreated, or we leave the old cows untreated. But what we don't know is one, does that work? We know adult cattle tend to have pretty low fecal egg counts. And so are they really contributing much to the Refugia if we leave them untreated? And then we also don't know what impacts it would have on production. There are some older studies that show increases in milk production based on calf weights, or some increases in reproductive performance when cows are dewormed. There's some more recent studies that don't show a difference, and we don't really have a great answer there for what impact does, if we choose not to deworm adult cattle, what impact does that have on their production? Interestingly, I tell you, we're working on a follow-up study right now to this study, and we've been looking at some fecal egg counts from some cow herds around the state, and many of the cow herds that have sent samples in from adult cows have very, very low egg counts. And so we're just not seeing much there in terms of parasitism in those adult cows. And so it probably doesn't do a lot for Refugia to leave them untreated, but it probably makes economic sense to leave them untreated, because then we're not spending all that money on an Anthelmintic product when there's not much in the cow to worry about. So again, we're not really clear on the best way to do this Refugia concept in beef cattle, but we think it's an important thing to consider and be thinking about, and maybe consider trying in your herd, particularly if you've identified that your herd has some resistance. Another option is the idea of combination therapy, and this is just using multiple dewormers at the same time of different class. And there's several studies that show that this is more effective than using either product alone. So you can even take two products that have some level of resistance when they're used individually. And if we combine those products, the combination can be much more effective. And that's what the premise is for the new Valcor product from Zoetis, is that it's two existing products. They've just combined them into one. And so it would be the same as giving those two products separately. It's just a lot easier to do because they're already combined into one product. And so if you have a herd and you've identified some resistance in that herd, using combination products may be a way to help combat that resistance. And there are places in the world where sheep and goat producers are using 3 and 4 different classes of dewormers at the same time to get any kind of viable response because of the level of resistance in those populations. We're not there yet in cattle, but we need to start taking some steps to try to make sure we don't get there. You think about how we administer our products, think about the route of administration for our products. And so theoretically, because the parasites are inside the GI tract, oral products have an advantage because they're delivered directly to where the parasites are. The unfortunate thing about our oral products is they don't have any kind of residual activity. So they work on the parasites that are there today, but those products are no longer effective come tomorrow in the animal. Our injectable products are kind of in between. And then where we see the biggest concerns and issues are with the pour-on products. They result in much more variable drug doses reaching the parasites. And so they are an area where there's a significant challenge. And again, we couldn't demonstrate that in our study because we had so much resistance. But we expected to see that herds that used pour-ons had a higher level of resistance, but we weren't able to define that because everybody had resistance. But there are several studies that show that pour-on products, they are less consistent in the amount of drug that gets to the parasite, and there's other concerns like licking. Maybe the animal, another animal licks some of the product off, and so the cow doesn't get the right dose. Some of the products are not rain tolerant, and so there's issues there. And the largest issue really is probably with dosing and the way the product is applied to the animal. So moving forward, I think it's important that our beef producers start thinking about assessing their Anthelmintic program. If it's working, stay with what you're doing. You may find that you don't need to even treat some groups of cattle, like the adult cows that I mentioned before. If you check a set of cows before you deworm them, and they have very low parasite counts, I mean, maybe you don't deworm them and save a couple $1,000s in Anthelmintic product. But if you find out that your program is not working, then we need to figure out why. Is it simply a dosing issue? Is it because there truly is resistance to the product? Is there other factors? And then think about maybe adopting some strategies to try to increase refugia. Make sure we're using products according to label directions. Consider using combination products, and then make sure we're reserving these Anthelmintic products specifically for their purpose and not using them for other things like fly control. So just summary, what we learned is that Anthelmintic resistance appears to be pretty widespread in Oklahoma beef cow-calf herds based on this small survey. It is encouraging that composite sampling looks to be a promising way to assess Anthelmintic response at the herd level. We need some more work there, but it does look encouraging. And we can say pretty confidently that what our beef producers in Oklahoma are doing currently for deworming programs does not appear to be working very well. Resistance to the product is probably a significant part of that. But we don't know, we can't say that it's only that. It could be other factors. But based on this survey for these herds, what the producers were doing for Anthelmintic product and worm control was not being very effective. So we need to look into those things more and kind of investigate that more. So we can't just assume that our traditional go out once or twice a year and give everybody some dewormer is going to be effective anymore. It was effective for a long time because the products were super effective. But at this point in time, that's not the case anymore because we do have documented resistance to all classes of anthelmintics, and also from a variety of production systems in different geographic areas. So it's not just a geographic problem. It's not just a particular grazing strategy problem. It's very widespread in the industry. We need to be more aggressive with monitoring so that we know when a problem occurs. And then we really need some more research looking at ways to practically do refugia in cattle programs because we just don't have a lot of data on that yet. We really need to start being proactive and adapting our parasite control strategies to this current climate of increasing drug resistance, and start adopting some strategies to try to minimize or slow down that resistance while still trying to maintain parasite control to a point that it doesn't cause a negative economic impact on the operation. So with that, that's what I got. I'm happy to take any questions, or if anybody has any comments or questions they want to share, I'm happy to do that. Dr. Biggs, I'll turn it over to you, and or Dr. Lallman, and go from there.
Well, we've had a couple of questions in the chat, but I think you answered those as we went along. So, but we may hit on those points as we go. Just as a reminder for all our participants today, you're welcome to enter any of your questions either in the Q&A or the chat. We do have one question in the Q&A right now, Dr. Gilliam. As far as economic threshold, we've talked about, we've got to, our ideal is that we address our parasites where we're not being economically impacted by them, right?
Right.
And so what's your guidance on measuring that? And is there a difference between cows and calves? Where does that threshold sit?
Yeah, that's a great question. The challenge with that question is there's not a good answer at this point. There's some data that says that as little as 10 eggs per gram of feces can have a negative impact on production, but we don't know if that's exactly right or not. So we don't have, unfortunately, no one's been able to establish a threshold and say, you know what, if you got 20 eggs per gram, you're losing money on those animals. If you're under that, you're okay. We just don't know that. We don't have that clear black and white threshold. We know fecal egg counts in cows tend to be pretty low. We know that parasites can have negative influences other than just weight loss or things like that. They can affect immune function and those kind of things. And we just don't have enough data to answer clearly, what is that threshold? But if they're down around 0, less than 10 eggs per gram, they're probably having some impact, but are they having enough impact to offset the cost of deworming them, for one? And two, is they having enough impact to that we ought to go ahead and deworm them, even though we know we're in this current climate where we need some refugia. So maybe the trade-off is we let those cows have a low level of parasites and try to maintain some refugia and save some cost on deworming that we may not really need. On the calves, it's probably a little different. We know growing animals they have less immune resistance to the parasites just because they haven't developed it yet over time. And then they're also still growing, and so the opportunity for negative impacts is a little greater. And so we probably still need to be pretty aggressive at controlling parasites in the younger populations of cattle. We just need to be wise about how we do that, and maybe consider some refugia-based strategies even in them. And so maybe the biggest, heaviest ones, we leave those guys untreated and treat the others. Again, we just don't have. We're very new in this process with cattle, and we don't have a lot of information yet in terms of research to be able to answer those questions concretely, unfortunately.
Well, and I think it's important. We started the discussion as in our first presentation of this webinar, where we talked about pharmaceutical stewardship, and that applies not only to antibiotics, but it applies to our anthelmintic products too. And do we have some short-term gains at the expense of long-term gains at some point? What do we do when we don't have any anthelmintics in cattle? Very similar to what we sometimes face in small ruminants at this point,
right.
that aren't aren't doing what we want them to do. So with that, how about a question on what do we do when if we're putting combinations together now? What does that look like when our combinations stop working? If we're putting products together, like can you maybe forecast it out what you might anticipate?
Yeah, I don't think the combination therapy is kind of the silver bullet, and where everybody needs to go start doing that, because we know that's going to still select for resistance. The information we have available tells us that using those products in combination, though, slows down that resistance selection. So what happens is you may have a parasite that's resistant to Ivomec, but that one is not resistant to fenbendazole, for example, if we're using those two products in combination. And so the total number of parasites that survive the treatment is significantly reduced because those products can kind of act synergistically. And so if we do it long enough, there's still probably going to be some resistance developed there to both products. But because it's not just that the ivermectin is killing, and it doesn't matter. I'm not using ivermectin, nothing against ivermectin, just examples to make it easy to understand. If the ivermectin it's not affecting this parasite population and the fenbendazole, a different parasite population. So again, one that may not have been killed by the fenbendazole might be killed by the ivermectin and vice versa. And so the total level of control is better. And if we add a third product, that even becomes a greater level of control. And so there's some concern there. And I think if we just simply went to combination therapy and continued deworming every animal every year or multiple times a year like we've done in the past, we're going to go down the same road eventually. It might take us longer to get there, but we're going to go down the same road. So I think the combination therapy is an important strategy, particularly if you have a herd that's already identified they have some level of resistance. But we need to incorporate that into a holistic strategy using Refugia, using some other of these concepts, so that we're trying to slow down that resistance using multiple tools. And we'll learn more as we go down this path. Again, it's a pretty new area in the cattle world, and so we're still learning quite a bit.
And that certainly emphasizes the things we heard from Dr. Navarre's presentation last week. Certainly complements the things we've heard today. I think we need to be discussing it. So, Dr. Gilliam, maybe one final question in these herds that you're their veterinarian, that maybe we haven't been, we've been doing what we've done for years, right? We've dewormed everything in the herd twice a year. We did it regardless, with not a lot of other information or other little other factors in it. Where are you starting that discussion with producers, or how should producers, maybe we got a lot of veterinarians on the line today, how should producers start that discussion with their veterinarians to be more strategic, to incorporate Refugia, to, again, as you said, take a look at the holistic approach to this? Where do we need to start those conversations?
Yeah, I think the place to start is to just start trying to evaluate, is what you're doing currently working? And the best way to do that is to do some fecal egg count reduction testing. It's the only way to do it. The only way to know if it's working or not is to measure it and see. And the only way we have to measure it is the fecal egg count reduction test. And so, and I've talked to some producers about this concern and say, hey, look, we start setting up plans to do our typical working of animals for the year, and we've dewormed everybody, every year, and think, do we still want to do that? And here's the reason maybe we don't want to do that. We're starting to see this concern about resistance, and here's maybe one strategy that we want to take to do it, or let's do some testing before we deworm. And we may find out that we don't need to deworm those animals. I mean, and it may be as simple as, if they're all near zero with their fecal egg counts, why spend the money to deworm those animals, and we can put that money to something else. Maybe that contributes some Refugia, maybe it doesn't, because the numbers are so low, but it saves you some money, right? It reduces the cost, the input cost going into the cow herd. And so that's kind of where I've been trying to start, is just like, hey, let's look at what we're doing, and is it working? Is there an opportunity to reduce some input cost? And just because we've dewormed every cow every year for 20 to 30 years doesn't mean we need to still keep doing that. But the only way to know that is to measure it and see. So that's kind of where I've been trying to start with my clients. Some are interested, some are not. But as we get more and more data, I think it'll be helpful. We'll have more information to go back on and say, look, here, here's a bunch of herds that we tested and they didn't have much in terms of parasites. And so we can just more supportive evidence there. So that's where I've been trying to start the discussion. As far as the Refugia goes, it's a little more challenging because, again, we just don't have a great way to do it. It would be nice if we could do it like we do in the sheep and goat world, because that works well. It's easy for producers to apply. But we just don't have as simple a way to do it in the bovine world. When I think if you've done some fecal egg count testing and found that your products are not as effective as you thought, then really that's an opportunity to start thinking about all these different strategies, and Refugia being one of those. If your product still looks pretty effective, then maybe it's still a good time to think about, okay, what are some things I could begin doing so that I can maintain the efficacy of that product? And we know Refugia, we know the concept of Refugia works. There's even been studies where people have gone into cattle with highly resistant populations of parasites and actually administered susceptible parasites to those animals and converted resistant populations of parasites to susceptible in a research setting. And so we know the concept works. The challenge is just how do we apply it in beef production? And we're still trying to figure that out and learning that. But, simple things like leaving some of the animals untreated, maybe not deworming adults, those are things that are pretty easy to do. I'm always just a little bit hesitant to go out and strongly recommend those to a producer, because I just don't have a lot of data behind, it says, well, what if I do that and it costs me a bunch of money in terms of production? Well, we don't have enough information to really answer that question yet. So I think the risk of that happening in cows is pretty low, honestly. In young animals, I'm a little more hesitant to leave them untreated. But a small percentage of them, particularly the larger, faster growing ones, they're probably ones that are a little more resistant to parasites anyway, and so they're maybe a good candidate for that. But that's all. It's all good in theory. We just don't have a lot of data behind it yet.
Well, and we're certainly trying to figure that out here at OSU. As you mentioned, we have an ongoing study based on your initial study that you discussed today. And so if anyone on the line today is interested in participating, Cabe has been kind enough to put that link in the chat. You can fill out that study link. If for some reason you find that study doesn't work for you, or perhaps you don't have the number of cattle to meet the minimum requirements for that. We've also put in the Oklahoma Animal Disease Diagnostic Laboratory, their website in the link, and you can visit with your veterinarian as well as the laboratory if you're interested in getting started with some fecal egg count reduction testing. And then, as always, if you're looking for any of our recordings of this series or any of our others over time with the Ranchers Thursday Lunchtime, you can see those in our archived bank of recordings, and we've put that link in the chat as well. So, Dr. Gilliam, want to thank you so much for sharing your research with us. We're glad we're getting that out and having a better start on addressing our parasite problems in a novel way as we look forward with that. So. With that, Dr. Lallman, have I missed anything?
I see Nathan's got a question here about that study link. Oh, link to study presented, meaning Dr. Gilliam's experiment. Okay.
That was published in Bovine Practitioner, right?
Yeah,
Dr. Gilliam?
I think it's published and accepted there. It has not come out yet, but it should be out this summer, or the summer edition will come up this fall. So it should be available in Bovine Practitioner very soon if it's not out quite already. But
right.
as Dr. Biggs mentioned, you will be able to access this recording of this webinar and could look back through his slides, his data, etc. And of course, you can find that on beef.okstate.edu. So yeah, thanks everyone for joining today. Cabe's got that link to our ongoing current fecal reduction or parasite resistance project, and that's we offer that free of charge. And if you do sign up for that or indicate your interest by filling out that form, you would be contacted hopefully in the next few days or week or so by your extension educator. So that's who would be working directly with you on that project. Thank you, Dr. Biggs. Thank you, Dr. Gilliam.
Absolutely. I want to
Next
add, Dr. Lallman, if we did have a number of veterinarians that joined us today, as I recognize their names on the attendees, if our veterinarians are interested in maybe a group of their clients participating in that project, you can either have them sign up individually by sharing that link, or we're happy to coordinate with you on getting those participants signed up. Want to encourage you to join us again next week for the final edition in this series, where Dr. Johnson will visit with us about new implant guidelines in bee production systems, and Dr. Johnson will join us from Texas Tech. So we've had really great presenters from a variety of universities in this series, and can't thank you enough, Dr. Gilliam, for spending a late night at the county fair and then rolling back into work and taking care of this presentation today. So with that, thanks again. We will sign off here. And as always, if you're needing additional information, visit us at beef.okstate.edu.
Thanks very much. Have a great day.